Okay, so we're trying to prove the cosine rule. So our proof, we're just going to talk through what we're going to do. So draw a triangle with vertex A at the origin. B is the point C0 and point C. And point C making an obtuse angle with A. Okay, so what that means is here's my point A, here's my point B, and here's my point C. Okay? So this is my triangle. Now that's C. This is why this point over here is C0, because it's opposite the angle C. Okay? This would be A over here and this would be B here. Okay? So you've drawn your triangle. Your next step is to draw a circle of radius B with center A. Okay, so you're going to get out your compass and actually do that. Center is at A, the point is at A, and the radius is B. Okay, and then you're going to draw your circle around. So draw a circle. Of radius length B with center at A. Okay, so it's going to look something like that. It doesn't actually go through that point B. You'll see it better when you draw with your compass. Okay.
Miss, do you write that in the theorem?
You do, yeah. In your proof, you actually write these steps out. Yeah.
Okay.
So now, because this is on a circle and my radius is B, that point C can now be written using sine and cosine. Okay? So when it's the unit circle, it's just 1 cos A sine A. In this case, your radius is B, so this point here is B cos of this angle and B sine of this angle. So that's that point C there. Okay, so we have BC. Okay, we're going to find the distance BC using the distance formula and these 2 points. Okay, so BC is the distance formula. C minus B cos A to B squared plus 0 minus B sine A to B squared. So just throwing it into your distance formula. You're going to square both sides, before you square both sides, instead of BC, we know that's called the side A. Okay, now my proof has A's, B's and C's. So I don't need a BC there. I'm going to replace that BC with A. So A equals this thing. Now I'm squaring both sides, so A squared equals okay, so the square and the square root cancel on the right hand side. Now what we're going to do is we're going to multiply it out, so A squared equals, so to square this out, square the first, product of the 2 multiplied by 2, so that's minus 2bc cos A, so that by that multiplied by 2, and then square the last, so minus squared becomes a plus, b becomes b squared, cos A becomes cos squared A. Okay, and 0 minus b sine A is just minus b sine A to be squared. So minus b to be squared is b squared sine squared A. Now, look at this. What's common to both of those is your b squared. Okay, so a squared equals c squared minus 2bc cos A. B squared is common, and I'm left with cos squared A plus sine squared A. What's cos squared A plus sine squared A? Yeah, thank you. Cos squared A plus sine squared A is actually equal to 1. So that bit there is just 1. So I get A squared equals C squared minus 2BC cos A plus B squared by 1. Okay, so all you're going to do is just rearrange it so that it looks like the question. B squared plus C squared minus 2BC cos of A. So now I've proved that. And then you just say underneath, similarly, it may be proved that your 2 other options are equal. Okay, so you can show that b squared is equal to this thing, and you can show that c squared is equal to this thing.